thing for a number of days was the difference between what we call group A problems and group B problems. Our group A problems, you remember, involved constant or average velocity. So in other words, we used this equation. It was the only option we had when we had a group A problem, when we had a problem involving constant or average velocity. But then we went on to problems where we had acceleration going on. We had 5 equations that we could use for acceleration. The first one was the basic acceleration equation. And then we had 4 other ones. VIT plus 1/2 ET squared. VFT minus 1/2 AT squared. VF squared is equal to VI squared plus 2AD. Big difference with this one is that we're dealing with final and initial speed, right, as opposed to velocity. Not a big deal, but it's a bit of a difference in that we're not going to get direction with those variables. The last one we had was D is equal to VI plus VF over 2 times T. So we know that this problem could be used whenever we had constant or average velocity. These equations could be used whenever we had acceleration. Well, a couple of days ago, we introduced the idea of acceleration specifically due to gravity. We said that every object that is under the influence of just gravity will always accelerate at a rate of negative 9.81 meters per second squared. Doesn't matter whether it's going up into the air and slowing down, or it's going down from the ledge of a cliff or the ledge of a building and falling under the influence of gravity. It will accelerate at negative 9.81 meters per second squared. So we're not saying that all those questions we did before involving group B problems, involving acceleration, will use this acceleration. What we're saying is that the new problems that we're doing involving vertical motion, involving falling or rising under the influence of just gravity, will be the same as the problems that we did for a week, but they'll have an automatic given. That automatic given is the acceleration due to gravity, negative 9.81 meters per second squared. All right, we had 3 questions for homework. Okay, 2 of them involved gravitational acceleration, and then 1 of them was thrown in there as a bit of a trick to see if you could distinguish between gravity problems and just other general group B problems. Those questions that we had for homework are on page 58. I would like to do question number 2, and I'd like to do question number 3 for sure. If there's anybody that would like me to go over number 1, I'll do that as well. But for sure, 2 and 3. Anybody for number 1 here? Nope, 2 and 3 it is then. 2 says, having scored a touchdown, a football player spikes the ball in the end zone. If the ball was thrown down with an initial velocity of 2 meters per second from a height of 1.75, how long is it in the air? Doesn't sound that hard. Okay, I'm doing it, and I picked that one to do for a reason, though. It is hard. Let's write down some givens. We know it's a group B problem. It involves acceleration, and we know specifically that acceleration is neg 9.81 meters per second squared. After the ball is released from the person's hand, it is under the influence of just gravity. Now, while it's being thrown down, there's another force acting on it, right? You're pushing it, but that's not what we're looking at here. Okay, we're looking at the trip down after it's released. So we're going to say, for question number 2, the acceleration is negative 9.81 meters per second squared. The same thing would apply, by the way, if I threw the football up into the air, threw it up. Okay, the acceleration would still be negative 9.81 meters per second squared. All right, what else we got here? We got something is 2 meters per second, and we got something is 1.75 meters. Can you tell me what the 2 meters per second is? Rosie? Good. That's going to be initial velocity, 2 meters per second. Can you tell me what the 1.75 meters is? It's going to be displacement. Good. Now, what are we looking for? How long is it in the air? We're looking for delta t there. Now, before I move on, there's a couple small typos that I've made there on purpose. Can anybody tell me what they are? They're small things, but they're important things. Nobody that answered one of my questions in the last couple minutes gave me a wrong answer. But something I wrote on the board is slightly wrong. What is it? Oh, sorry. Yes, that's not the one I made on purpose. You're right. Displacement should be just meters. Yeah, that was a unintentional little typo, but it's still wrong. Yeah, good. Velocity and displacement are supposed to be negative. How come? Rosie, how come it's supposed to be negative? Good, because they're throwing it downward, right? The displacement is negative because the football ends up below where it started. The velocity is negative because you're throwing it downwards, right? All right, we're looking for delta t, a, vi, d. Oh, I see a nice simple solution to this, right? V is equal to delta d over delta t. I can rearrange that. Delta t goes up to the top, v goes down to the bottom. Oh, this is easy then, right? Delta d over v, is that right? Delta d is 1.7, negative 1.75 over negative 2. Oh, wait, it doesn't give me the answer in the book. What's wrong with what I just did? What is fundamentally wrong with what I just did? Not just some little mistake. This is a major mistake that I just made. What is it, William? Well, yeah, it doesn't include acceleration, but there are situations sometimes when you can solve a problem and not use all the givens. Most times you use them all, but not always. Okay, we have the initial velocity there, and this is just v, not vi. Yeah, that seems to kind of, yeah. Yeah, the big thing is this is group A equation, right? This is not a valid equation here. We cannot ever use that equation unless it asks me for the average velocity. Okay, if it's asking me for the average, then I could use it. But otherwise, I got to use a group B equation. Okay, it doesn't matter if it looks like it fits the givens. It doesn't quite, right? Because Riley told me that it's VI instead of V there, but it almost fits the givens. Doesn't matter if it fits the givens or not. Not a valid equation. Okay. What step did we skip when we're solving this problem? We like to talk a little bit about the problem before we look at our givens, right? Is this a group A? Is this a group B? What equations are valid? What equations are not valid? Okay. We skip that. We skip that this time. Don't forget to do that because that's going to lead you sometimes to something that we just did. Okay, this is a group B problem. I got to use one of those group B equations. Okay, which one do you want to try? Well, it looks to me like this one might fit. VIT plus 1/2 AT squared. Anybody else try that one? It's the one that looks like it fits to me. I got D, I've got VI, I've got A. Don't know what T is. Okay, it's in two places, but it's the same variable. Okay, that's a problem. That's a problem. How many of you have ever used in math class something called the quadratic equation? Negative b plus or minus b squared minus 4ac. In order to solve for delta t here, we would need to use the quadratic equation. And not all of you have even heard of it, let alone used it. You will never in physics 20 need to use the quadratic equation. There'll always be another option for you. Doesn't mean that there's never a situation where you can't use it. You can use it here. If you're comfortable with it, go ahead and use it. But my suggestion to avoid the quadratic equation in this question is to say, look, I know I need to find t. I can't do it directly. So let's get something else. Something, it doesn't matter what. Solve for something. Okay, solve for something. Let's try VF. VF squared is equal to VI squared plus 2AD. All right, let's get VF by saying it's the square root of 2 squared. Hey, why did I drop the negative there? Why did I make it 2 squared, not negative 2 squared? Yep. Sorry. You can't square root a negative, but I can't just arbitrarily drop a negative because it doesn't seem to work math-wise. I dropped the negative there because VI stands for initial. What was I given up here? Initial velocity. What does VI stand for here? Initial speed, which doesn't have a negative associated with it, right? Doesn't have a direction. So just 2 squared plus 2 times negative 9.81. See, I put the negative in here, right? because A is a vector. Displacement is also a vector. We do the math there, we get 6.1915 meters per second. All right, that's not what I'm looking for. Is that wrong though? No, listen. If I gave you a whole bunch of data about my car that's parked outside right now, and I said, I don't know, I traveled 100 meters in this amount of time and whatever. I said, what's its average velocity? And you said, your car is blue. Is that wrong? No, my car is blue. That's right. Did it answer the question? No. But it's okay to recognize that my car is blue. It just means you're not finished. Okay, you haven't finished the problem. Okay, we're not finished the problem here. This is right. We're just not finished the problem because it's not what we're looking for. So let's use this piece of data that we just got to solve for delta t now. Maybe we'll say d is equal to vi plus vf over 2 times t. Oh, this is a little bit weird to solve for t here. We got to get rid of this entire term by multiplied by t. Let's divide it. Delta d looks messy, but it's correct. Vi plus vf over 2 equals t. We got everything to plug in there now, so let's do that. Delta d is negative 1.75. Vi was, what was it, negative 2? Plus VF, 6.1915 over 2. Oh my goodness, is it ever ugly? Equals T. Is it ever ugly and wrong? Made another little mistake in there on purpose. Good, Rosie. The final velocity should be negative. But wait a second, it said positive 6 up there, right? Why is it positive there and negative there? Yeah? Good, good. This was final speed that I solved for. Now, what did I want? Final velocity. I couldn't get final velocity that way, but that's okay because I know that it was moving downward. So I can tack on the negative myself because I know that it was moving downward. This variable up here didn't tell me that it was negative, just my brain told me that it was negative because when you throw a football downwards, it moves downwards. All right, now we can solve this. Let's pull out the calculator to do that. Okay, bear with me on this one. Let's do the bottom here first, okay, because this is pretty ugly if we try to do it all together. Let's say negative 2 plus negative 6.1915. Let's divide that by 2. So that's the number on the bottom there. Now let's say negative 1.75, divide it by that number on the bottom, 0.42. So my time is 0.427. Is that the answer in the book? 0.43. How many people got that one? Good for you. Good for you. Tough question. Anybody do it using the quadratic equation? Okay, what'd you get? Okay. That's the thing with the quadratic equation, right? Is it just gets so messy. Like it's doable, but it just gets, I don't know. When I was in high school using the quadratic equation, negative b plus or minus, it just got so cumbersome that it was so easy to make a silly mistake with it, I found. So this would be my preference, but do whatever you want, as long as you're good with the quadratic equation. Okay, good. 3. An elevator moving downward at 4 meters per second experiences an upward acceleration of 2 meters per second squared for 1.8 seconds. Explain that to me. Explain that to me for a second. How can an elevator moving downward experience an upward acceleration? It's moving downward. It doesn't say it all of a sudden starts moving upward. It says it's moving downward and experiences an upward acceleration. Okay? No. if it's moving downward and going faster, that's a downward acceleration, right? A negative something acceleration. Yep. Oh, it's just the opposite of what both of you guys said. When you're going downward, you're slowing down. That's an upward acceleration. It's a positive acceleration. Okay. If you're moving downward and speed up, that's a negative acceleration. If you're moving downward and slow down, that's a positive acceleration, an upward acceleration. So this elevator is going down, you're slowing down. You're slowing down to stop. All right. What do we got? It's a group B problem, but look at this. It's not just the influence of gravity here. So this is a group B problem, but it's not a gravity problem. Okay, this is not one of the problems we've been working on. They threw this one in there to see if you guys could distinguish between what we've been working on and what we were working on. We're going to say VI is negative 4 meters per second. We're going to say the acceleration is positive 2.00. Even though it's moving downwards, it's accelerating upwards. The time is 1.8 seconds. We want to find VF. I'm going to say, I think for this one, A is equal to delta V over delta T. T goes up by multiplying. So delta V is 3.6 meters per second. 3.6 meters per second. We're going to say delta V is equal to VF minus VI. VF, take the VI over by adding. So it's going to be 3.6 plus negative 4, which gives me negative 0.400 meters per second, which is what they say, right? 0.4 meters per second down. Hey, how many people got that? Okay. Then we're looking for the displacement. How far has it traveled? You got a couple of options here. We could go back to this, or we could use the number we just found. VI is negative 4. A is positive 2 this time. When you do that math, you should get 3.96, negative 3.96. Let's try another example here. Clown. A clown throws a ball upward at 10 meters per second. It's the maximum height the ball reaches. How long does it take to do that, Megan? What do we got going on here? Clown throws a ball upward. Does that ball travel at a constant velocity as it moves upward, or does it accelerate? Accelerate, decelerate, whatever. It accelerates, yeah. It's a group B problem, right? It's a group B problem. Now, is it a group B problem involving gravity? Do we know the acceleration is neg 9.81, or is it something else? Once the clown releases the ball, it accelerates, it slows down at 9.81, right? Because it's under the influence of just gravity at that point. So let's write that down. Okay, we know that A is negative 9.81 meters per second squared. We know that VI, going upward, is positive 10.00 meters per second. Whew. Is there anything else we have here? Yeah? What's VF? Good. Good answer. VF is 0. Okay. Ben, how did you know that VF is 0? Good. Good. It stops only momentarily and then it goes back down, right? But when it reaches that maximum height, and for us, that's the end of the problem, right? When it reaches the maximum height, we're not analyzing the trip down. We're just analyzing the trip up. That's the end of the problem. VF at that point would be 0 meters per second. If you throw it up and it stops, VF is 0 meters per second. Now we're looking for the height, the displacement, when VF is 0, and we're looking for the time there as well. Listen, this question isn't any different than what you've already done now. It was just This question was just given to you to see if you could recognize what Ben recognized, and that is that VF is equal to 0. Let's say VF squared, maybe. VF squared is equal to VI squared plus 2AD. Solving for D. Take the VI squared over by subtracting because it's not attached. Take the 2A over by dividing. So 0 squared minus 10 squared over 2 times negative 9.81. How do they round that? 5.0968 rounded to 3 digits. 3 digits because the 9.81 would be 5.10 meters, right? Isn't math elegant? Like you might not like math, but it's elegant. Like it just works out so neat. Like it's such a tidy, elegant subject. In the end, like, you know, we make gravity negative because it's a downward acceleration, and it's VF squared minus VI squared, but VI is positive because it's a scalar. And look what happens. We end up with a positive displacement. It works out to be what it should. Right? You throw a ball up into the air, its displacement is positive because you threw it up into the air. If you had thrown it down, its displacement would have been negative, and it just would have worked out that way. Solve for T here now. Probably the easiest way to do that is to go back to this equation. Delta V is VF minus VI, 0 minus 10 over negative 9.81. Again, like we want a positive time, right? And it's worked out to be a positive time. 0 minus 10, negative 10 over negative 9.81. So have a look at the one question on page 59, please. One more example, and then we're finished. This stuff. A clown throws the ball upward at 10 meters per second. Didn't we just have this question? Same context, but a little bit of a different question. This time we want to find the time that it takes the ball to return to the clown's hand from the max height and the ball's final velocity. So instead of, in this question, finding out how high the ball goes and how long it takes the ball to go that high, this time we want to find out how fast the ball is moving when it comes back down, and we want to find out how long it takes to come back down from the maximum height to the clown's hand, or to the clown's hand. Right? So what do we got? Well, we know it's group B, right? It's acceleration, and we know it's a gravitational acceleration because this is going up and coming back down. A will be negative 9.81. Let's write some of that stuff down. Where VI would be 10 meters per second. Anybody have any suggestions here? Yeah, Fraser? Oh, so you want to use the same data from before? Okay, fair enough. This was the same context, right? We throw it up at 10 meters per second. It's going to go 5.0968 meters high. We could find that again. Right, we could find that again if we wanted to, but we do it exactly the same way. So save ourselves the bother, just copied it from the last question. Is D 5.0968? Actually, not really. D is negative 5.09. Remember the last question, we were finding out how high it went up. This time we're dealing with how far it goes down. Same distance, right? But it's going to be opposite sign. And you know what? VI isn't really 10 meters per second either. If we're analyzing the trip down, VI would be 0. You guys catch that? VI is 0, not 10 meters per second. We needed the 10 meters per second to get this, But we had already gotten that in the last question. So now I'm going to say VI is 0. This is how fast it's moving when it begins to fall. We want to find how long it takes, and we want to find VF. Let's say D is equal to VIT plus 1/2 AT squared. VI is 0, that's good. Solve for T here. The 1/2 A goes over by dividing. And then the square goes over by square rooting. A few minutes ago, we were talking about the elegance of math and how the signs just work out. Look, we made D negative 5.09. Negative by negative is a positive. Look, it works. It works again. 1.019 seconds, which we're going to round to 1.02 seconds because we used 3 digits there. All right, VF, probably VF squared is equal to VI squared plus 2AD. VI is 0. Watch what happens when you do this. Oh, look at this. I am so good. I am so smart. I can do this in my head. 2 times negative 9.1 times negative 5, square root that. 10. Am I so smart? Was I able to calculate that in my head that quickly? Yeah, I knew it was going to be 10. I knew it was going to be 10 right from the beginning of the problem, because if I threw it up at 10 meters per second and it reaches a peak height and comes back down to where it started, how fast is it going to be moving? 10. Now, if this didn't work out to be 10, something's wrong. I made a mistake somewhere, right? I wasn't smart. I was just observant. That's all. By the way, I was looking for final velocity, so it should be 10 meters per second downward or negative 10. How come I didn't get a negative 10 right there? Because I was calculating final speed, not final velocity. Yeah. All right, I want you to work on this question for now, page 60. And then when you're finished that one, I've got a number of other questions for you to work on page 63. Those questions that I want you to work on page 63, in addition to this one, page 63, number 2 to 16.